The next generation iPhone design by Justin Wong. The main problem I found with the iPhone generations nowadays is the durability of the iPhone. It's very common for people to drop or have their iPhone slip and it will fall into a hard contact area and crack or shatter. And although Apple has developed a hardened glass to make it more scratch resistant and shatter resistant, it's still glass. It will still break, and when it does break, it's really expensive to have Apple replace it, and it's really hard to replace it yourself. So I wanted to see if I could improve on that. For brainstorming, I listed some pros of stainless steel and hardened glass, of what those are the two materials they do use in their iPhones, and I thought of using titanium and an epoxy resin. Titanium has a lower density, so its strength to weight ratio is higher than stainless steel, and it's less prone to fatigue under temperature conditions and normal wear and tear, but it is more expensive. Epoxy resin is very tough. It's flexible, so it's less likely to shatter. It's also scratch resistant and easily shaped. For planning, I thought of 3 different models incorporating those materials. One model is a full titanium back, which is strong. It won't shatter. It is not completely scratch resistant, but it can be buffed out. However, this will be quite expensive. For the second model is just a titanium skeleton, or the frame, replacing the stainless steel with titanium. That will cost less. It uses less titanium, and it will still improve the strength of it, but it will still use glass. And the third model is a titanium skeleton with a resin encased hardened glass back. This will have a stronger frame, a stronger back. It will be more shatter resistant and still scratch resistant, but manufacturing will be more complex in the process. So for the testing phase, I would test the different models in similar scenarios of dropping it, plunging it in water, flex, and other tests, and I would record those results for each version and compare which has the best results, lowest cost, least complex to manufacture, and other results. Then finally, I would improve on the model with the best results and then try to change the design to strengthen it, keep down the cost and complexity to make the optimal model.